Hello everyone. So today in this video I am going to discuss about your acceleration. Then I'll derive the equations of motions by graphical method. In the last videos I have uploaded already two videos from this chapter, part 1 and part 2. So in those videos, if you'll go back and check in the playlist, so you will find that I have already completed the definitions of velocity, then speed, distance, displacement, and also we have solved few numericals from average velocity, average speed, and uniform motion, non-uniform motion. So all these concepts we have discussed in our previous videos, right? So today in this video we will discuss, that is your chapter number 3, motion in a straight line, and in this chapter we will discuss the concept of acceleration, the area under velocity time graph, that is your VT graph. We will discuss about that, and from VT graph we will derive your equations of motion by graphical method. So these equations can be derived also by calculus method. That one we will discuss when we will introduce calculus. After that we will derive the equations of motion by calculus method. Now in this video I am going to discuss, I will derive them by using your graphical method. So now first we will discuss the concept of acceleration. Basically we are discussing here the average acceleration. The instantaneous acceleration case, we have to use the calculus method, that is differentiation. If a velocity is given in a function of t, right, then we can calculate acceleration by differentiating that velocity. Instantaneous acceleration we can get. So that the use of calculus, differentiation and integration we will discuss in the next classes. So today we will use the graphical method and the average acceleration case. So first, what is acceleration? Your acceleration is the rate of change of velocity. How fast the velocity is changing, that is your acceleration. Suppose you are driving a car and suddenly you accelerate the car from 30 meters per second to 50 meters per second, and this acceleration, this change in velocity happened in 5 seconds, right? So how fast the velocity changes, or the velocity change in velocity per unit time, rate of change of velocity, you can say this is your acceleration. So we can write that. What is acceleration? So acceleration is A is equal to V2 minus V1 by T2 minus T1. That is final velocity. What is V2? V2 is the final velocity, V1 is the initial velocity. That means suppose this is your car and the car was moving with 30 meters per second. Suddenly you accelerate it, you increase the velocity. Now when you increase the velocity, the car speed increases. The speed of the car increases and the speed changes to, let's say, 50 meters per second. And this change happened in 5 seconds. Within 5 seconds the change happened, right? And so what is the change? So 20 meters per second. This is final velocity. This is your V2. This is your V1. And this change happened in, the duration is 5 seconds. So what is the acceleration? Final is 50 minus initial is 30 by 5. So 20 by 5, 4 meters per second square. So what is the acceleration? That is the rate of change in velocity per unit time, or rate of change of velocity, that is your acceleration. And meter per second square is the SI unit of acceleration. What is the unit of SI unit of acceleration? Meter per second square, because velocity by time. So velocity is meter per second divided by second, meter per second square. So SI unit of acceleration is meter per second square. Okay, now we will discuss velocity time graph, VT graph, then we will discuss area under VT graph, right? we will discuss in one particular class. I'll take one class to discuss all the graph, like displacement type graph, then your velocity time graph, acceleration time graph. So we'll discuss all the graphs in one class. So today we'll discuss just velocity time graph, that is, we can say it is VT graph. This is VT graph. So what is VT graph? VT means in y-axis I have taken v, velocity, this is time. Now if I draw this line, can you recognize which type of motion is it, or what you will tell about the velocity of the object? If the one line I just represented, it is parallel to the x-axis, that is your time axis here, then what does it represent? What does it represent? This line, this parallel line, what does it represent? Does it represent any what type of motion is it here? So here you can say that velocity is parallel, means here velocity is not increasing. All the points on this velocity, each point is fixed, means constant, right? So here you can say the object is moving with a constant velocity, that means 40 meter per second. Continuously it is moving with 40 meter per second, it is not changing the velocity, right? So here the velocity is not changing. So when the velocity will not change, you can say this type of graph also acceleration is 0, because acceleration is change in velocity by time. So here velocity is not changing, so you can say acceleration is equal to 0 here. Acceleration is 0 here, right? Now you can see one thing. Now if I draw one area, so this is like a rectangular one, and this one is suppose starts from 0, so the velocity is v. Now this is your time. So rectangle area is your height into length into breadth. So here velocity into t, and velocity into t will give you, we know, the displacement. So here the area v into t is displacement, but here in this case your v into t is your area. So you can imagine this, just I gave you one example. So in all the cases, whatever the graph may be, in all the cases the area under the VT graph or VT curve will give you the displacement, right? So this one you remember. So the area, you can note down this, that area under VT graph or VT curve is displacement. Area under VT graph is displacement. It can be, the area may be like this also. So if you draw this one, so this area will represent your displacement of the object, right? So VT graph can be any type, but the area under that one will give you the displacement. So from this concept we are going to derive the equations of motion. Equations of motion means when the object is moving in a straight line, it will obey certain laws. When the object is moving in a straight line, it will obey certain laws and certain mathematical equation it will obey. Such mathematical equations, like it will be related with your displacement, velocity, acceleration, time. All these combinations will find out certain equations, and these equations will be, means any motion will obey this equation if they are moving in a straight line. Now let us derive these equations one by one, then you will able to understand. And the basic concept we will derive by that we will use in the graphical method is your area under velocity time graph. So you see the area under this is suppose the graph, VT graph. This is your VT graph, right? Velocity time graph, and the object starts from, let's say, at a initial velocity u, and it moves up to the final velocity v, right? So if I join this line, then we know that this area under this VT graph will give you the displacement. So what relationship we can find out? We can find out. So we'll join one perpendicular here. Now you can see this one is a rectangle and this one is a triangle. So now the sum of area will be area of rectangle plus area of triangle. Now before that, you can see that what will be this distance? It will be v minus u or not? This will be v minus u, because the final one is v and the initial one is u, right? Final one is v and initial one is u. So this difference will be v minus u, and this one is your u and this is your time, this is time t, right? Now you see, if I say this is your v minus u, right? This v minus u is the change of velocity here in this graph. What is the change of velocity? That is v minus u, and this change happened in what time? What is the time duration? In t time, right? So this is the definition of acceleration, right? So this is how we will get the first equation of motion. The definition of acceleration is change in velocity by time. So in this case, from our graph here we can see that the change in velocity is v minus u, change in time is t, so v minus u upon t, that is your acceleration. So now if you will cross multiply, you will get that v minus u equal to at. This is your first equation of motion. This is your first equation of motion, or you can say v is equal to u plus at. Now we will go for the second equation. So first equation, how did you get this? We just derived this by using the basic definition of acceleration. Basic definition of acceleration is change in velocity upon time, or rate of change of velocity. So here change of velocity is v minus u, and the time duration for this change is t. So v minus u upon t is your acceleration. After cross multiplication, we got this relationship. So this is your first equation. This one is a equation, v is equal to u plus at. Now we will go, or we will derive the other equations. Basically we will derive three equations here. So here you can see two more equations we are going to derive. So second equation will derive using the concept of the area under VT graph. So as I told you, what is the area involved? So the total area within VT graph is, let's say, if I'll name it O, A, B, C, D. So area of A, O, A, B, C, D, trapezium. It's like a trapezium. You can use the area of trapezium directly also, you can use, but what I will do, I'll find out the area of this shaded region, sum of this triangle plus rectangle. So what should I do? This area is equal to area of this ABC, OABCD is equal to area of triangle BCD plus area of rectangle OABD. Now what is the area of this triangle? It's a right angle triangle, you can see. Area of right angle triangle is half into base into height. So you can write that this is half into base is t and height is b minus u. So you can write V minus U into T. This is your area of triangle, and area of rectangle is length into breadth. Length is U and breadth is time. This is U and this is time T, right? So you can write that area under this shaded region is your displacement. So you can write S is equal to this one, and half into V minus U T plus UT. Now can I write that V minus U is equal to AT from the definition of acceleration, or from the first equation also I know that V minus U is equal to AT. So I will replace this V minus U as AT and T plus UT. Yes or no? Yes, possible. I replaced this V minus U as AT. Clear? Now what shall I do? This S is equal to, this is my half AT square plus UT, right? Half AT square plus UT. So I can do this. So this is my second equation, that S is equal to UT plus half AT square. This is your second equation. This is the second equation. Now we'll go for the third equation. We'll derive the third equation, right? So how will you do the third equation? Let us derive it here. The third equation, again we will take the same area formula. Directly I am doing. So area is equal to triangle area plus rectangle area. So triangle area, as we have written, that is half B minus U T plus UT. Area of rectangle UT, area of triangle B minus U into T, right? This is difference. This is B, top point, initial velocity U, final velocity minus initial velocity is difference in velocity. Now area is your displacement, and this one you can write, simplify. This is half BT minus half UT plus UT. Now see, plus UT minus half UT, what will be the result? If you think like minus x minus half x plus x minus x by 2, what is the result? X by 2, right? If you subtract from a number to a half, then you will get a half, right? So UT minus half UT, what you will get? So S is equal to half BT plus half UT. Why plus half UT? UT minus half UT is half UT plus half UT, right? So what you will write? S is equal to, take common half. You can take half common, right? So half is common here, and T also common. So V plus U into T. Now see, I will replace this T here. What shall I do? I will replace the T here. Then what shall I get? So T, we know that our formula for your base acceleration, the formula of acceleration is what? That is V minus U upon T is equal to A, or you can write V minus U by A equal to T, just interchanging the position of A and T. You can write this. Now I will write this instead of T, I will write this. I will just want to rearrange and get one more formula. So what I will do here is, this is my S, right? So S is equal to, my S is equal to half B plus U, and this T I will replace this one. This is my B minus U by A. Now you see, A plus B into A minus B, B plus U minus B into B minus U, A plus B into A minus B. What is the formula? A square minus B square, right? So you can write here S is equal to half B square minus U square upon A, right? Now we got another formula. This 2 into A, which is in the denominator, I'll just cross multiply. I'll multiply here, so I'll get 2AS is equal to B square minus U square. This is your third formula. So what we have discussed in this class? we basically discussed that the concept of acceleration, and the area under velocity time graph is the displacement. Then from graphical method we derived three equations of motion. Basically, first equation we derived from the concept of acceleration. Second and third equation we derived by different rearrangement from the concept of area under velocity time graph is the displacement. And what are the three equations? Let me write down. These three equations we will use. These are fundamental equations of object moving in a straight line, and they obey these equations. So many problems are there, you can solve them by these equations. So equation B is equal to U plus AT. Second one is S is equal to UT plus half AT square. See, second and third, this is nothing like, if no one will ask you what is the second equation of motion, it's not like that. So you can write second in third or third in second, no issue. So V square minus U square is equal to 2S. So these three equations are called equations of motion. Equations of motion. These three equations are called equations of motion that you will use in different numericals, and you can solve many problems. And also in the next class I will derive one equation, that is formula for S(nth). Okay, that is motion in nth second. First, suppose what will be the motion of the object, or how far the object will travel in 3 seconds, in first 3 seconds. So in those cases we will calculate S(nth). Okay, or what is the motion of the, or what is the distance covered by the object in its 10th second. Okay, 10 minus 9th, that duration is 10th second. So all these things we will discuss. S(nth) basically we will derive, and we will also solve the problem based upon the S(nth), right? And differentiation calculus method is there. So 2 to 3 or 4 part will be there in this chapter. Then this will be a complete chapter. After that we will solve few numericals, and we will go for the fourth chapter, that is motion in a plane, in the after few classes. Thank you for watching the video. See you in another video. Bye bye.